Every identical twin starts as one fertilized egg that splits into two. Most of the time that split happens within the first few days, and the two halves go on to develop as separate, straightforward mirror images of nothing in particular, just two matching people. But in about 1 of every 4 sets of identical twins, something different happens. The egg waits longer to split, sometimes as long as 12 days after fertilization, and by that point, the embryo has already started building its own sense of left and right. That timing difference is the entire explanation behind what scientists call mirror image twins, identical twins who are still genetically the same, but who end up as physical reflections of each other instead of matching copies. Every embryo, twin or not, has to figure out which side is left and which side is right. That process starts remarkably early, driven by a set of genes that establish what scientists call the body's left-right axis, well before the embryo has anything resembling a face or limbs. In a typical identical twin pregnancy, the split happens before this left-right patterning is locked in, so each twin builds its own independent axis from scratch, and there's no reason for one twin to end up as the reverse of the other. Mirror image twins are different because the split happens after that axis is already partially established. When the single embryo divides around day 7 through day 12, each half inherits a piece of that same left-right blueprint, but from opposite sides of the original structure. One twin ends up developing from what would have been the left portion, the other from the right, and that positioning gets carried through the rest of development. The result shows up in traits tied to that early left-right patterning. Most commonly is handedness, the direction of hair whorl on the scalp, or which side a birthmark or dimple appears on. Roughly 25% of identical twins show at least one of these reverse traits, according to research published in the journal Twin Research and Human Genetics. The left-right axis isn't some vague biological suggestion. It's controlled by a specific, well-studied set of genes. One of the most important is called PITX2, along with a signaling molecule called Nodal, both of which switch on early in development to tell cells which side of the embryo is which. This system is so precise that when it malfunctions on its own, without any twinning involved, it can cause situs inversus in a single non-twin individual, which is actually how researchers first started studying the pathway decades ago. In mirror image twins, the split simply happens to occur after this genetic signaling has already committed each side of the embryo to a direction. So the two resulting twins inherit opposite ends of the same left-right decision. Most mirror image traits are what researchers call ectodermal, meaning they come from the embryo's outer cell layer, things like hair and fingerprints and skin. That is why the vast majority of mirror twins look and function completely normally. The reverse traits are cosmetic, but in rare cases, the mirroring goes deeper than skin and hair. A condition called situs inversus can cause one twin's internal organs, including the heart and the liver, even the stomach, to form on the opposite side of the body from where they normally sit. On its own, situs inversus shows up in roughly 1 out of every 10,000 births in the general population, and it's not something usually a person even notices unless a doctor happens to order an imaging scan for an unrelated reason. One well-documented case involves a pair of identical twin sisters named Tiffany and Trissy, both diagnosed as infants with situs inversus totalis, meaning their major organs are fully mirrored. Researchers who studied the twins as adults found them to be nearly identical physically, within a 1/4 inch in height and matching exactly on weight. And both twins tested as right-handed on a standard handedness questionnaire. But the mirroring showed up in an unexpected place: how they used their hands for everyday tasks. When the twins worked together at a bank, one counted cash by holding the bills in her left hand and moving them to her right, the typical pattern for a right-hander. Her sister did the exact same task in reverse. Both women went on to build separate ordinary lives, where one became a registered nurse and the other a full-time parent. Proof that a fully mirrored internal anatomy can come with a completely healthy life. The mirroring effect doesn't stop at birthmarks and hair whorls. In one documented case, a pair of mirror image twins both developed the same type of lung cancer, and the tumors appeared in mirror image locations within their chests. Cases like this suggest that whatever biological patterning drives the physical mirroring can in rare instances extend to how disease develops in the body. Not because the cancer itself is inherited in a mirrored way, but because the underlying structural layout of the twins' bodies is reversed to begin with. For years, scientists studying the genetics of handedness ran into a problem they couldn't explain. Identical twins share the same DNA, so if handedness were purely genetic, every pair of identical twins should share the same dominant hand. They don't. Roughly 20% of identical twin pairs are discordant, meaning one twin is right-handed and the other is left-handed. And mirror image twins are a major reason why. Researchers eventually found a workaround. They could check how early a set of twins split by looking at their fetal membranes in the womb. Twins who separated very soon after fertilization developed their own separate membranes, while twins who split later, the group mirror twins come from, often share membranes instead. That distinctions let scientists finally account for the mismatch, and it turned out handedness itself is driven far more by environment and chance than by genetics. Studies comparing identical and fraternal twins found that about 80% of both types show matching handedness, right around the same rate, which would not happen if genetics alone were in control. Splitting late also pushes an embryo closer to a second, more serious threshold. Past around day 13, a delayed split no longer produces two separate embryos at all. It produces conjoined twins. Mirror image twins sit just on the safer side of that line, close enough to explain why their development looks unusual, but early enough to still result in two fully separate individuals. Mirror image twins have picked up a reputation that goes well beyond hair whorls and handedness. Plenty of claims online suggest mirror twins have opposite personalities, opposite emotional temperaments, even a kind of psychic connection tied to their reverse development. None of that has any basis in the actual research. The reversal that scientists have documented is limited to physical traits tied to the embryo's early left-right patterning, ectodermal features like fingerprints, hair whorls, and the rare case of situs inversus. Personality is shaped by a mix of genetics, environment, and individual experience, none of which have any connection to which side of a 2-week-old embryo a cell happened to end up on. The science here is genuinely interesting enough without needing to invent a psychic angle for it. What started as a single fertilized egg, splitting a few days later than expected, ends up building two people who are genetically identical, but who spend their lives as each other's reflection instead of each other's copy. I remember my 6th grade teacher was a mirror twin, which I thought was cool, because I'm an identical twin, so it's always fun to learn more about this type of stuff, and I love making these videos. Thank you so much for watching this one. I have so many cool videos coming in the future, so I'll catch you in the next one.